Welcome friends, welcome back to our YouTube channel Crystal Learning. So today we will discussing a important concept of differentials in train. So this topic might fall in the subject of theory of machine or automobile engineering or automobile subject. Okay, so this is the topic which was asked in an interview panel by engineering services. So the question was asked that is differentials are present in metro train? If not, then how the metro train take turns? Okay. So this was the question. So this was the question. So we see that the answer is there is no differentials in train. So what happens when a train takes turn? So let's see the explanation that what should be the explanation. So this is the geometry. We are taking left turn. So these are the two wheels joined by a axle and rigidly joined means this is not independently turning like this inner wheel is turning in some different RPM and outer wheel is turning with different RPM. They will turn with same RPM. But when we are taking turn, we know that due to geometry, that inner wheels have to cover short distance and S2 has to cover more distance. How? So this inner wheel distance from the center is arc. It is subtending an arc. There will be some radius of curvature. And this outer is R2. So we get S2 equal to R2 theta. S1 is equal to R1 theta. So theta is common and we know R2 is greater than R1. Therefore S2 is greater than S1. So this condition is there. So, so how, just wait for a minute. So now we will see that what is happening during turning. So we have assumed that N1 is equal to N2 or outer wheel RPM equal to inner wheel RPM equal to N because it is rigidly fixed. Okay. So in one complete circle, distance covered by one wheel is 2 pi r or a circle because wheel is in form of circle. So for inner wheel S1 will be, or for if we talk about one revolution, then it is 2 pi r. For n revolution, it is 2 pi r n. So we are calculating the distance of inner wheel, that is S1 in that rotation. It will be 2 pi r I n. In traveling S1 distance, the number of revolution is n. For outer wheel, that is S2 is 2 pi r O n. Ri is inner radius of inner wheel radius and Ro is radius of outer wheel. So these are the distance covered by inner wheel and outer wheel. We know that S2 is greater than 1. Okay. So therefore, what will happen? 2 pi r naught and 2 pi r I n. It should be greater than. So we know that 2 pi will cancel and n remains same in both, so n will cancel. So for achieving this condition while taking turn, radius of outer wheel has to be greater than radius of inner wheel. This is the condition. Like if you will satisfy this condition, then only you will be able to take turn, that to left turn. So this condition is achieved by coning of railway wheels during manufacturing. So whenever you visit a railway bogie or railway station, just try to observe, not coming to the track and just seeing the wheels. Then the train might run over you. So whenever a train is standing and there is like empty means empty station where only a train is there, there is no train is coming or going, always be alert. Okay, so just try to see a wheel. So what you will see, there is a coning means normally we see a wheel means this region is flat. okay, horizontal. But here we have a cone shape, and that too in downward direction. So what will happen taking in left turn? So when you will be taking left turn, due to centrifugal force, this wheel will be pushed outwards. So when you this wheel is put outwards, you see the contact area is this, and you see this diameter is larger than this diameter. Okay. So here we get D outer greater than D inner, or R outer greater than R inner. So this condition is achieved by manufacturing the wheels in cone form. So this would be the answer for that interview question. That due to coning of wheels, we are able to take turn in a metro train or in normal bogie trains or passenger trains, because we can't use a differential, because train that bogies are quite heavy, so they might break. So we use this coning concept. I hope you enjoyed this lecture. Meet you next time with a new question.